Yo everyone, how are you doing? Hope you're doing well. I'm Tobias and today you'll be learning out how to create this robotic arm in Houdini. So let's get started. To model the robotic arm itself and skeleton, I'd recommend a different DCC package like Cinema 4D. This is what exactly I've done. I created the model first, mapped it out onto the skeleton so all the distances are correct and all the positioning of the joints are correct as well. But a strong tip before you export to Houdini, make sure that all the different parts are zero-centered to the world axis, including the skeleton. You can see the origin of the skeleton is right here. I've moved them apart just for demonstration purposes, but otherwise you should always keep it zero-centered, because Houdini will then rearrange all the different positions onto the skeleton, but if you already have a transformation present, it's going to offset your arm parts somewhere else in the world, and you don't want that. You want them to be laid out specifically along the skeleton. So once you've done that, bring it into Houdini. I'll just get another file node and let's create a new example. So here it is. It's quite massive, so we can scale it down a bit. Once we're happy with that, unfortunately we cannot get our named groups out of Cinema 4D from name, but we can use this node here to add our names back, and we want them as primitive. And we're doing this because we have to split our skeleton and geometry. Like that. We're going to be working on these two different parts separately. So once we have our skeleton, let's turn the grid on. We have to reparent it, otherwise the eye keychain won't work correctly and we're going to have very messy results. So to unparent, first we have to unparent to then parent. We can get our parent joints node, that comes second, and a normal add node, that's going to come in first. So add this, and you click delete geometry but keep the points. Boom, and everything's unparented. Now we bring in parent joints, and I can't remember what order you had to work in, but like this, I believe. Joints to parent one. No, other way around. Okay, so it's like this. From the root to the tip. There we go. So now when we're happy with that, we can add another add node here. And we're gonna need 2 points. One is gonna be from the point at which the eye keychain will be bending, which is from the top, and the next point is gonna be the tip, the destination, where the robotic arm is going to where we're going to want it to reach. So let's bring the gizmo back in. This point can be somewhere here. Actually, you want point. This is point 1. All right, that's good. Point 1 can be the knee, the bend point, and point 0 can be the destination. So that's good. So once we have that, we have to create our eye key chain node. And for that, we need a rig attribute VOP. So that goes in. How do we do it? That goes in there. That goes in there. I'm going to color this blue to make it stand out a bit. Here we need a few parameters to determine what point numbers are we going to use. Integer. We're going to need 1, 2, 3, 4, 5 parameters. So we need the root point, share underscore, and the label can be the same. Then it's the midpoint. Then it's the tip point. Dear. And then it is the twist point, or at least the point at which the whole bending will take place. Twist point. Okay, and the last one is the goal or the destination, which is this 0 point here. Goal point. Okay, so for the first three, we want, actually for all of them, we need point transforms. So get point transform. Okay, we're gonna need 1, 2, quite a lot, 4, 5. We know 2 bone I key. This is what we'll be doing the solving. And set point transform. That's what we also need. We need that for 3 points because we're using 2 inputs. 1 input is for the bend and the destination, but we're only transforming the I key skeleton here, so we're only going to transform this point. Actually, we're transforming all of them, but it's driven by the 3 points. So let's get 1 and 2. So now we have to connect everything. Connect that there. Lot of connecting. But if you make it this way, this is more or less how the I key. This is what the I key chains used to be before a certain update, but then they locked it out and you cannot. Now you have to use names, which is a bit silly, especially for a simple example like this, just so you understand what's going on. With naming, I would have to create additional nodes and blah, 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 blah. Nobody wants to do that. So we're just going to be doing it in VOLPs. Once we're happy with that, we have to connect this, correspond the get to the set. Like that. This one too. And this one too, I believe. So for these last 2 ones, we need the second input, not the first one. Is this for the first input? Yes, it is. Okay, let's just keep it a bit... It's gonna get a bit messy, alright? So get prepared for that. Let's connect it backwards. Like that. Okay, so... Now let's connect the goal and the twist. And now the root. And the root driver, that goes there as well. That's the mid. And the tip goes right there. Okay, so with everything connected, let's check it out. Now we have to match everything. So let's go back here so we can see the point numbers, although we still can. So the root point is 0. The midpoint is number 2. The tip point is number 4. Now if we go here, the twist point is 1. And the goal point is 0. So let's turn on the visibility flag here and let's try making changes. Will you look at that? We have our I key system working phenomenally well. And if you move this twist point downwards, you can see that it does the twisting in the opposite way, which is not what we want. Let's just keep that really high up somewhere so it doesn't bother us. Yeah, fantastic. All right, so we got our skeleton. And so now we have to somehow attach the geometry. Let's turn the grid off because I can't see anything. Right, so we're going to need a few more steps. We have to separate each individual part from the split node of the geometry. So let's get our delete nodes. 1, 2, 3. How many parts? I think there are 4 parts to this robotic arm. The first part is this. Second part is this. And then it's female piston, then it's the male piston. and delete non-selected. Okay. Hold on. Now we need to actually attach the geometry to the skeleton, and we're going to do that using an attribute VOP, color it blue or something else so you can so it stands out from the rest. And we're also going to need an up vector, because the geometry itself has to know which way to orient, which way to face, and we have to tell it to face upwards. So let's create that quickly. Type vector, value 1 up, N, fantastic. So we've got our skeleton waiting here, it's all ready. Now we just have to do the matching process for the geometry. So bring that, connect that to that, and connect your skeleton to the second input and to the third input. This is just the way I've been doing it based off a different project I was working on as well. But because you'll be you're gonna have to make this flexible for different parts as well, I'll show you how to create it with parameters, and you can recycle the same process over and over. So to attach the geometry to create this node, we need 4 parameters. Let's bring them in. 1, 2, 3, 4. So we need the up vector point. I'm doing this as a separate parameter in case you would want the robotic arm to spin independently of world axis. Let's say you have a big rig, a character, and the character has a robotic arm on it. If the character's walking up a slope, the up vector is going to change to whatever the character is facing, and you need to feed that into your into this node. Otherwise, all the geometric pieces will still face upwards, and it's going to look bad. It's going to break because the geometric pieces won't align with how the character's orientated in the world. So the way I do it, I just like to keep this as a separate parameter and to have a separate input for the up vector. But if you have the up vector, if you have the normal on the different nodes, then you can just merge the 2 parameters together, use 1 parameter for the 2 different things. So now we need a get attribute. Let's move these global things out the way, and we need 3 of those too. So for the first we need hold on, this is gonna be the vector, third input, this is a second input, and this is a second input. For these 2 we want the P attribute, and for this we want the N attribute. So, and for this, why can't I make, alright, I'm gonna have to do it like that. And parameter, let's call that up vector, label as well. Then look at point. And then we want the look from point. I can do that the other way around. Look from. Because we're working with 2 points. The first point is where the geometry gets actually attached. That's where the pivot is. And the second point is where is it going to direct to, which way will it be pointing. So if I have one part of the robotic arm, and let's say I specify point 0 and point 3, it wouldn't align with the skeleton because it would look directly at point 3 in a straight line. So that's why we need 2 different points. So we have the look from, we have the look at. And also I like adding a parameter just to reverse the orientation if the geometry is flipped, or if something flips in the skeleton. You may have it that the geometry, the root is actually on number 3, not on number 0, but the geometry is facing the opposite way. So I just add an option to flip between the 2 in case that did happen. I'm just going to call it flip. Just like that. We all want integers. Fantastic. So let's now connect everything together. Like that, like that. It's a lot of connecting. Now we want our look at constraint. So we want that to be from that's the up vector. So steady. So we will connect that very much later. That's from. That's 2. And we have to make another one. Swap these around from 2. This is our up vector. Okay, we have a bit of a little bit of a mess, but it's not that much. So now we want switch node in case in case the switching did happen, and the switcher goes right here into our flip. And then we want them extract transform, because we have to apply the transforms into 3D space. That goes there. Now we need our global things, which is what will actually change the position of the points. Was this one? I think transform, that's it. Now we want to connect our rotation here and our point here, position. And we have to output this. Just like that. Okay, I think everything is in order. So once we're happy with that, let's just come back here. Let's turn on our ghost view for the skeleton so we see it aligns correctly. Turn this off. Now we can start messing about. So up vector, this point is 0. All the points have our vector value. So look at, actually we have to look at it a different way. We have to see what point numbers we're dealing with. So 0 and 2, this is our first one. So look at 0 and 1, 2. Now this may happen that you've exported stuff. You can see that it is kind of aligned, but at the wrong axes. So just bring in a transform node, just pop that in there. And you have to sometimes make a few random rotations. This is not the one. This is not the one. This is not the one either. So we have to just play around. There we go. -90. Fantastic. That's the first one done. So now we just bring in... Actually, if this transformation is correct, I can just copy it over to all the other different parts and make the corresponding connections. Okay, now for here we just connect, and connect to our VOPs, and then merge all that together. It's like that. So this is our second part. And we don't need all those ghost views, just the one ghost view. Right, now we're dealing with the second part. So for the second part, we need 0.2 as the root, and it's looking at number 4, at 0.4. So look, 1, 2, 3, 4. Interesting. Why is it still from 0.2? No, that is correct. That is correct. So what is the deal? One, two. Hold up. I missed anything. Oh my god, yes I have. Hold on. That needs to go there. That's it. Oh, for God's sake. Alright. Thank God I found it. You can never be too sure of what you're doing, because you may end up doing it wrong. So we have to add a transform as well. We have to actually give it the freedom to move. Transform, because it can rotate. We've got the position where we don't have the transformation. There we go. So now it should work great. So you can see that it's flipped. So let's 2, 3, 4. Oh, wrong one. 4 like that. That's good. And if we do it the other way, and if we flip it, this is what I mean with the flipping. It's not the same flipping like you would do it here. That's a different type of flip. There you go. So that is correct. So now for the next part. This is part of the piston. I think this goes... Look at 1 and look at number 3. Yes, I think that's correct. And now for the last one. Oh, bugger. Number 3, look down at number 1. And with more or less just that, we got ourselves our robotic arm. Doesn't look that bad. Of course, there are some changes we have to make, like with this. Right here, you can see that the pistons are not fully aligned, and that's because when I was working in Cinema 4D, this was how I originally made the robotic arm, and then I had to flatten everything out, kinda eyeballing it, and you can see that this eyeballing is having an impact on the precision. It's not a problem though. We can go into our transform. This is not the right one. This is not the right one. Now, if we've got 2 elements, do not pull one element right down. You have to do it 50% this element, not like that, and 50% the other element, like that. Because if you do it just with one element, the other element is still going to remain bent, and if things are in motion, you're going to see that offset, you're going to see that error still persist on one side of the piston. So remember to balance it out. If 2 sides are off, then you have to balance out the 2 sides equally. You can't just balance it using one side. Now here, using the, I don't know if it's because of the look at or something. No, where is this messing up the normals? But that's no problem. Let's bring in one of them. And all our normals are looking fantastic. So to control your robotic arm, you just go into this little add node. You can use a rig pose node as well, which is a bit better. The controls are a bit better. But for me here personally, this works absolutely fine. And there you go, guys. Robotic arm in Houdini, a pretty simple way. Not the simplest way, but you have a very high degree of control over every single step. You've made this little procedural VOPNet tool that you can use for all your other projects. Here there's a link above to a different project I've been making with a spider, like a robotic spider. The leg is far more robust, so if you're interested, check the link above, not below. And I'll have more interesting stuff coming in the future. If you're interested in robotic stuff or After Effects or Cinema 4D, just stay active on the channel and let me know what you think, and I'll see you in the next one. Hope you learned something. See ya!